All right, now that we cracked the water bottles, it's time to get started. So welcome. My name is John Carlson. I serve as the Senior Vice President for Cybersecurity Regulation and Resilience at the American Bankers Association. And I am joined by two very talented people in the financial services industry, technology industry, that also service the housing industry. We had a third panelist who was supposed to join us today, Michael, from the National Fair Housing Alliance. But unfortunately, he is ill today, so couldn't join us. What we're going to cover today is we're going to talk about emerging policy issues in the housing and financial services industry, given all of the radical changes that are taking place in artificial intelligence. And I'm going to first ask each of our panelists to briefly introduce themselves, their roles at their organizations, and a little bit about how they got into this AI space to begin with. So we'll start with Stefano.
Stefano Pasquali. I am leading the team called Investment AI in BlackRock, and basically my team is supposed to use this technology, mathematical modeling, to financial analytics to support the investment process for trading, portfolio construction, etc. And clearly now the name of the team has never been more appropriate now. How I enter in AI, the first time I saw neural network in my life, I was a physics student, so coming from physics, there was the first hype, everything disappeared, now everything is appearing magically now with all these LLMs, so what we do, and basically we are trying to serve the investment process with insights and analytics.
Great. And then Nick?
So my name is Nick Schmidt, and I'm the AI practice leader at a consultancy called BLDS, which is based in Philly. And what we focus on are applying economics and statistics to questions of law and regulation. And in my work, I had the model audit and model validation practice. So what we focus on in that practice is performing model audits, understanding whether a model is reasonable and being able to attest to that. We focus on explainability, and finally, really where my specialty is in algorithmic fairness. And so out of my work at BLDS, I ended up founding a software company called Solas AI. And what Solas AI does is it enables companies to input their models into our software, test whether or not there's evidence of discrimination using metrics that are standard across regulatory and legal settings. And then if there is an issue, our software actually tries to find a fairer algorithm that is still highly performing, so that ultimately our customers are able to put models into production that they understand are going to be as fair as possible.
Great. So what we're going to do is we're going to talk about a number of different aspects about how AI is impacting financial services and housing, talk about some of the risks that we're dealing with in the industry, what we think the future might look like. We'll also sprinkle in this some activities that are occurring at the policy level in terms of the U.S. federal government has released a sweeping executive order on artificial intelligence, and basically directing multiple government agencies to either update or write new rules and develop new standards around artificial intelligence, as well as to try to find ways to leverage the technology to better serve consumers and Americans in general. We will have time for your questions. I know there's the app. I think if you look at the back of your name badge, there's a QR code on there, and we'll be getting the questions coming in a little bit later in the panel. So let's kick it off and talk a little bit about the fact that AI is not necessarily new. Certainly in the industry and in financial services has been using AI and machine learning for really decades now. But with ChatGPT, it's really democratized it and opened it up to a whole new generation of users and tremendous capabilities with continuous improvement. So let's level set a little bit in terms of how do financial institutions in the housing sector use AI today?
Okay, I start?
No. I'll take you first.
Okay, and basically, so in terms of less sexy name, financial modeling, we've been doing this statistical method and techniques, machine learning, potentially even a neural network for a significant amount of time. The spike of evolution in the last few years is driven by three things that happen at the same time. The evolution of computational power was much more available and cheaper. The ability to consume much more data, and there are two necessary ingredients to train larger and more performing model. And so 10 years ago, we knew about deep learning. I didn't see any production application of deep learning because same story. It was very difficult to train this model, to collect the right amount of data to have a meaningful training on this model. And plus was computationally very inefficient. Somebody invented this different variation of deep learning, one is transformer behind ChatGPT, and this became suddenly scalable and much easier. And then the rest is history. So I think what we see is an exponential growth of this opportunity to train this model, and so we are able to train foundational model, what OpenAI did and many other open source models they start to train. And I think this provides, we see in BlackRock the AI, impact of AI in three different pillars. One is efficiency gain. So now I can I ask the AI to prepare to me a draft of email for my boss. We know Italian accent, not error in a grammar, and I can review this draft and send this draft. This is efficient gain. I'm faster in doing my job in a safe environment, and there is always the human in the middle, and we can review this part. The second part is what we call the user experience. Now I can interact with our insights, with our platform much more efficiently without going to standalone application that can be very rigid and difficult to develop. The third part where my team is mainly involved is how we can enlarge the amount of analytics and models to support the investment process, to provide insight and support to our decision making, and in particular, back to the performance before, how we have the opportunity to make this model much more performing. So if I try to describe a transaction cost model for the market, that's what my team used to do for the last 10, 15 years, with the linear regression, the performance of the model cannot go above a certain level. With more complex machine learning techniques or even deep learning, the performance is for sure going much higher. With the responsibility that I think is, when I touch this topic, that the more we add complexity to these models, can be for numerical application, for language application, the more we higher performance, but the more we are less in control of the model because it's a large number of parameters, sometimes pre-trained by others. So the part of governance, transparency, interpretability becoming a key now, and we are clearly a lot focused on this.
Great.
And I think in what I've seen in the industry, in housing, financial services, and really more broadly as well, I think everybody's moving in these directions. But where I see a lot of the use, you can differentiate between generative AI and machine learning. And it's really important to do that because there's so much hype around generative AI and there's so much going on around it. While it's very exciting and there's a lot of opportunity, it can be very easy to ignore these algorithms that are very much driving a lot of decisions by companies that need to be investigated, need to be understood, need to be validated. And so what I see in the industry with generative AI is that most major companies are trying to figure out what to do, and they haven't figured it out yet. Everybody wants to use it, but the problem is it doesn't work very well very often, and it gives really bad results occasionally, at least occasionally. And so what you really need to do, and what we recommend that companies do, is roll it out in very clear, very limited trials and have it internally tested, not have much, if any, public-facing use of generative AI, and then go from there. And what we're seeing is that companies are using it for productivity enhancement. And that, I think, is a very good use case and relatively low risk. So things like code completion, building out marketing content, summarizing documents, all of that Gen AI can do pretty well if you have someone behind the scenes making sure that it's right. And that's what we're seeing financial institutions starting to do. Where I think the other issue is really in machine learning more generally. And these are algorithms that have been around for, I mean, you can consider logistic regression a form of machine learning. So, that's 50, 60 years. Perceptron was, 1954, I think? So this stuff has been around a lot for a long time, but it's really gathered steam. And that's been because of massive improvements in the algorithms themselves. Things like gradient boosted trees have just really driven an explosion in growth. The algorithms and the computing power has made a huge difference. And finally, the data that actually go into the algorithms. There's so much more data than there was before. And to use that data, you really need to use these more complex algorithms. So I see these algorithms being used in pretty much every aspect of financial services, starting with marketing. That was where it was first really used because those were considered the lowest risk settings. Then it eventually went on to pricing and underwriting of loans. And it's become reasonably well established. I think of all of my customers and clients, virtually everyone is now using at least gradient boosted machines in order to do underwriting. And then servicing is kind of maybe the final frontier in the adoption of machine learning. And that, I think, is actually potentially the most dangerous from a regulatory and compliance area. But beyond just the use of these algorithms, there's that data aspect, and it's data and third-party vendors. And that's another area that I think can oftentimes be ignored that really should not be, because you end up in a situation where you're not recognizing potential problems with data quality or potential problems with vendors building models that either don't include what they say they include or they're not really sufficiently performative. I looked at a model by a vendor last week, and what we found was that from the time of production, or the time the model was trained, to the first year in production, the relative quality of the model dropped by nearly 50%. And any bank that's implementing that model suddenly lost a lot of money. And so what I really encourage the institutions to do is not just adopt these things quickly, but adopt them smartly.
Yeah. Well, you've actually a really nice segue into kind of the risk management challenges that I think any industry that is leveraging AI is grappling with right now. Financial services, and to a lesser extent housing, has a very heavy regulatory oversight mechanism, lots of rules and regulations around how to manage risk generally, how to deal with model risk management, obviously anti-discrimination requirements in terms of what are the outcomes of these models and how can they be in compliance with regulatory requirements. There's also just unintended consequences, from the use of these technologies, and how does that impact the firm and liability issues associated with that. So why don't we go to you first, Stefano. Talk to us a little bit about what are the risk management frameworks that organizations are using now, and also leveraging what they already have in place.
So we've been having since the inception a very strong severe models management framework where we identify classify into the different type of models, the different type of application where they are risk-free, but potential tax summarization. There is always the concept of the human in the middle, so most likely you can take higher risk there in hallucination, but still you need to have some framework to support the final users. And going through more complex models that are used in more mission-critical or business-sensitive applications. So we always have this models management framework that every time we build a model, we route this model in production, in function of the application, we have peer reviewers that analyze this model, we expose the data, we need to declare and show in details how we acquire and clean the data, how we handle anomalies in the data, the training process, etc. And we have a regular model surveillance application that validate if the model is still doing the job it's supposed to do. Clearly, for linear regression type of problem, tree-based approach, gradient boosting, we use a lot of these techniques already in production, is kind of easy. And now what every company needs to do in functional differentiating needs to evolve this modeling management framework. I usually tend to hate acronym, but in this case I really love the acronym XAI, that stands for Explainable AI. And I think that it really classify very well the series of methodology and tooling that are necessary to provide tools to do the next, the model surveillance 2.0. And there is already a lot of research done, a lot of implementation done, and we are clearly heavily involved in this, in particular, even with my team, where at the end of the story is you cannot think to have an implementation of a large language model without having some level of centralized engine providing you the probability of hallucination. Then probability of hallucination is, you can accept my example about the draft of my email. If I know that this draft from my boss is hallucinating with 20% probability, I don't really care because I review the email myself. If even 1% probability is coming from a structural sentiment from financial news that we'll be using for trading or the routing execution, that to me is unacceptable high level of hallucination. So in function of this, I think we need to have different type of policy, methodology, evolution of the framework. We are doing this and plug into this process the right set of tools. Mm-hmm. And again, it's not we call this. We are all focused on generative AI and LLM, but there are applications of this methodology for time series forecast. Yeah. Really is a big topic for us. So I think the part of the machine learning component, the model surveillance, and the XAI tools that provide a level of transparency and understanding on the output of the model for numeric application, language application is a must.
Well, what do you think of the NIST AI risk management framework? Is that a useful tool?
I think I want to comment. It's bigger than me to comment if the NIST framework is right or not. But I think they correctly identify all the blocks that are necessary. So basically, actually, with my team, we are looking this framework and say, okay, for this first block on the data quality, very specific data quality, what do we need? For model interpretability, from scoring the model, etc., what do we need? And we need just one-shot validation and periodically monitoring of the model behavior, maybe for some low-risk application, yes. For intraday AI-sensitive type of application on this model, we need a different type of surveillance and tools that provide this. So there is work to do, and we're working, and even the vendors are starting to realize this problem. And so there are a lot of proliferation of research in academia and vendor and open source library that provide to people this tooling that you can understand, validate, and customize or develop on your own.
Yeah, great. Nick?
Yeah, I think it was 2 years ago I had read that there were 150 different AI frameworks out there, and I would imagine that's probably tripled or quadrupled since then. And so there's this real tendency to think that everything has to be thrown out and you have to start from scratch in terms of understanding how to measure risk with AI and manage risk with AI. And I think that's actually largely wrong. The regulations and the practices that the financial services industry already has in place are largely very good. There's a regulation called SR 11.7 by the Federal Reserve, and the OCC has a model governance template and model governance procedures. Those are amazingly robust to AI and machine learning. But there are ways in which AI and machine learning are different, and I think that it's very important to ask what those are and then provide additional work around those areas when you're thinking about how to make fair and safe AI. And explainable AI, XAI, is probably number one. And an important consideration of that is not just can you explain your really complicated algorithm, because chances are your explanation methodology is actually an approximation. So the second question you can ask is, should I even be using such a complicated algorithm? And there's been a whole there's been a huge amount of work over the last year or two about using interpretable machine learning models. And a lot of techniques have developed where you can actually have a much better understanding of what the algorithm is actually doing without having to do these, they're called post hoc explanations, that can oftentimes be pretty wrong. And that sort of work, I think, is really valuable. So that's, sorry, I kind of went off on a tangent there, but thinking about the issues with existing frameworks, explainability, another big one is the brittleness of machine learning models. If you take a credit underwriting model that is built for prime customers and you apply it to near prime customers, a traditional model based on logistic regression will not do as well, but it's not going to tank. A machine learning model may very well tank. And that's because these models are very population specific. And so understanding that is very important in governments, both in terms of how you utilize these algorithms once they're let out into the world, as well as how you test them. And so things like value at risk, knowing how much the bank has at risk if there's a 1% change in interest rate, say. That's a very different problem for a machine learning model than for a logistic regression or an OLS. And knowing that is essential. In addition to the two regulations I mentioned, I think the NIST AI risk management framework is really amazing. It was amazing that they were able to get all of these disparate companies and disparate industries together and come up with something that was so useful. It is by necessity not specific enough for an individual industry to use. But that's by design. It is, as I understand it, and I think people from NIST are speaking later, so probably shouldn't go into too much detail. My understanding is it's a very top level thing, and you are going to have specific frameworks and guidance and policies for your industry and for your use case, but it really did capture all of the big issues.
And if I can add on this, I totally completely agree. Despite we are, I mean, particularly my team, we are all people coming from physics, mathematics, statistics, so we like innovation, we like a complicated mathematical problem to solve, but I always ask to my guys when they face a problem with my model, I want to see the linear regression first.
Yeah.
Because there are plenty of literature proving that tree-based approach can overperform deep learning. And there are plenty of with the difference that with tree-based approach, you have actually high way to control understanding how the model perform and why the model spit out a specific forecast. With deep learning, a large model with large parameters, you don't necessarily have. So all this best practice, to your point, is already very well defined in model management framework. Simply now with the additional complexity, we need to leverage additional tools to perform this job. And then what the XAI framework is helping a lot.
It kind of touched on a lot of different things. I mean, you certainly mentioned the importance of management of third parties. So I want to kind of tie that idea with my next question around the issue with data. So AI is heavily dependent upon a lot of data, but we all know that garbage in, garbage out is a result if you don't have good data. So what can you do in order to mitigate the potential risk of bias, data drift, and as we've talked about earlier, lack of explainability?
My guys, the job description of people in my team before was called data science, so data scientist, that has the word data as a fourth part. So data were important, catastrophically important for linear regression, are even more important now for large model, independent if you train this in-house or even more if you use pre-trained model from third parties. So the part of data governance is becoming even more important than ever. Actually, we are investing a lot on this. Paradoxically, the advent of this new technology actually provide very novel type of techniques to do data quality. So one thing, for example, that I don't see enough mention in a technical conference, I think now is raising up the concept of synthetic data generation, and not to generate synthetic data, but in order to have potential proxy of data to validate the data you have. So the problem of data quality that was been always difficult and mainly driven by a rule-based approach with pros and cons, actually have an opportunity to scale and become more powerful using these techniques. We are doing a lot of investigation on this, but for sure, data quality cannot be ignored. And a right level of assessment in the case of the model is pre-trained by a third party is important. I'm super happy to see the proliferation and the explosion of the open source type of model, because this means that there are many people working on those models, and there are many people vetting those models. So it add a layer of vetting that is significantly useful. But the problem of model surveillance, having a right way to monitor the input data, in particular for calibration and training, is difficult because you do this only once, and sometimes it's done from third party. But the inference in production, estimating this model, I think is super important to have tools that do the X-ray of the data that goes in and do some level of validation and scoring on the output of this model. But I think this technology is creating a lot of scale. So in all these parts, we're talking about generative AI, the chatbot, but there is all these tools for the model behind the curtains, so the mathematical model to generate insight, and how this technology actually can help to the governance part and to the data quality and anomaly detection.
So the data is such an interesting problem, and it's really important to get down to it and understand it, because on one hand, all of these new data streams have the ability to capture information about customers who were previously foreclosed from the primary financial market. So I think it's 45 million Americans don't have enough data with credit bureaus to be scored with a FICO or a Vantage type score. All of them are forced to payday lenders, loan sharks, or just completely out of the market. Many of those people are credit worthy. But to understand that, they don't have the credit data, so you have to go to alternative data sources. Things like utility payment history, rent payment history, and then more and more tangentially related history. And there's a question of whether or not that's valuable and worth it. Because on the one hand, you may be bringing more people into the mainstream financial system. On the other hand, there are data quality issues there. Things like data collection can be really miserable, and they can be more miserable by protected class. So when I look at alternative data, oftentimes I see that it's missing for Black or African American applicants or Hispanic applicants at a much, much higher rate than it is for whites. And ultimately, when you put that data into the algorithm, missing data usually doesn't help people. And so there's a real issue there. The other thing that is really important beyond errors in the data is actually for people to consider how discrimination enters the data and then enters the modeling process. Because your solution to discrimination does depend on that. And the example that I really like to give is that the White House guidance that I think we're talking about, and virtually everybody who talks about this stuff talks about representation. And are minorities sufficiently represented in data sets on which algorithms are being built? And a lot of that comes from examples in facial recognition and text recognition, where if you do not have enough minorities in your photo recognition, you're going to get way more errors. And there was one study that showed the error rate for identifying gender for women of color was 35 times that of the error rate for white men. And that is obviously unacceptable. And the solution to that is to get more people of color and more women into the data that is being used to train the model. Go to the credit example. The data that is used to build a credit algorithm can incorporate the bias that is present in the model. And so your FICO score, or that's actually a bad example, in other information about you that goes into the score, there are relationships between race and those variables. And those ultimately are going to manifest as differences in outcomes, differences in approval rates. And in fact, the worst thing you can do for minorities is make their data more representative or use a model based just on minorities, because that data incorporates all the discrimination that that group experiences. Instead, you want to treat them as society in the whole or the really privileged group. And that's how you can extend equity. So understanding this data is really essential, understanding the background of it, making sure it's not error prone, understanding missing rates, and then seeing and visualizing, conceptualizing how it ultimately leads to discrimination or data drift or any of these problems is essential to fix it.
Yeah, we've gotten a few questions that are coming from the audience, and I want to kind of combine some of the questions that are coming in with the ones that we had talked about. And this is really more talking about like the future, where do we think AI is going? And the question that came in was talking about what you think the role of computing power and advancements in quantum computing. And that is, to me, is also closely linked to the importance of cloud service providers, which really are the backbone for processing AI applications. So let's talk a little bit about where you think the technology is going to go. And I think, Nick, you had already kind of hinted that there's already some reservations about how to adopt, given the risks and given the regulatory issues in financial services. But kind of talk a little bit about where you think it's going to go and what the adoption rate will be.
It's really amazing how much tech has changed in the last 5 years. My laptop can run very quickly any credit underwriting algorithm by any major bank in the US and do it in a minute or two, and likely less. So there are a series of algorithms that have become very common that don't need to be faster. When it comes to large language models and generative AI, I think quantum computing is going to be incredibly helpful for things like climate modeling, problems that are very complex, multidimensional, that may not be quite AI, maybe more chemistry or physics problems. Those are problems that are going to be much easier to solve with quantum computing. So it's a really interesting world we're living in, because there's actually a lot of it that I think has matured. But there's this whole other side that will get better as computing power increases.
For sure, the computational power on classical computer is exponentially increasing every quarter. I was in California for a couple of conferences, actually more on the hardware side, and I was impressed to see what in terms of computational power last year was unthinkable. So are we going to see a lot of evolution in the dedicating computational rack for specific AI large model application, and I think this is a trend. On the quantum computer, being a physicist, I was dreaming to see a quantum computer before I enjoy my retirement. I have hope that's going to happen. I think we need to understand that when quantum computers is going to be a revolution in terms of computational power, but for specific type of algorithm. So will not replace classical computer. Classical computer can delegate to quantum computers part of the mathematical reasoning, and typically for what people are technically in the room, people that are Monte Carlo simulation optimization problem is what this quantum computer will be potentially revolution. Every year I go into some event where people that decide they start to estimate our 5 years away, 10 years away, 15 years away, I don't know. Yeah. Sleeping on the watching window and waiting for the dead day. But I think we're going to see for a few years classical computer and AI interacting together before to see a quantum AI application industrialized in production.
Yeah. Anything you want to add?
Okay. No, I think we got it all covered there.
Yeah. We've talked a little bit about in earlier panels, we talked about what the government, U.S. government's been doing, and I'm not going to ask you to comment on the executive order, which I mentioned at the top, was a sweeping, directive from numerous agencies. I know I was personally involved with some work that the U.S. Treasury Department just published last week that focused on the impact of AI on cybersecurity and fraud and what the industry and the government can do in order to combat that. Because clearly, I think that's one of the bigger risks that we're going to encounter, particularly with deep fakes being very effective in tricking people and much more sophisticated phishing emails that we're already dealing with in terms of the fraud that occurs as a result of that. But I want to generalize that a little bit in terms of what do you think would be helpful in terms of on the public sector side to really enable the industry to leverage the technology, but to do it in a way that is, appropriate, risk managed, do no harm.
I think that it's important to realize that principles like fairness, accountability, transparency are not at odds with innovation and are really quite important for successful long-term innovation. And I would like to see the government providing more clarity to industry about what is expected of them and what they can do. I believe that it really needs to, any regulation, any legislation needs to advocate a more principle-based approach with enacting regulations offering sort of guidance on these are practices that would be helpful. But I would hate for regulations to come down that are overly prescriptive that ultimately end up causing more harm than good, where people are able to either design around them or innovation is stifled because of them. And so I look to, again, the SR 11.7 as a really strong guidance for how good regulation can be enacted. On the other side, there's a current version that's not yet finalized. Colorado State released guidance for assessing discrimination in insurance algorithms, and it is remarkably prescriptive. And you could easily be found guilty of discrimination according to these methods while being absolutely fine. There's also it's probably not too hard to design your way around them so you never have a problem. And that's problematic. And so I think that more principle-based approach is really what is needed.
We've gotten a few questions I think are really interesting. This is to Stefano. What are some of the newest and best performing data / sources for financial prediction models?
For me, the advent of this large language model in general, this transformer, is the ability to do better the foundational data science work that is unfortunately data collection, data cleaning, and then feature engineering. So for us, we see an immense value to extract for unstructured data, text news, PDF document, some numerical features that we can plug in the downstream model. So I think this is extracting numerical insights and features from textual news or PDF filing is becoming much easier, much less expensive, and more proficient. So we can generate features that add to the model, can be a tree-based approach that doesn't have to be a deep learning model, improve the forecasting power of the model.
Great, and this is actually an interesting question for you, Nick. It really kind of dovetails with the lunchtime fireside chat. And the question is, with respect to underrepresented groups, where do you find an appropriate data source that does not reflect existing biases?
Well, that would be magic. Unfortunately. And what you can do, and this is what our company specializes in, is you actually can tweak algorithms, determine which features are driving disparity and which ones are ameliorating it. You can also change the algorithm itself, change the hyperparameters, even switch to a different type of algorithm. And what you can find is that you can, in fact, make models fairer. And what it's doing under the hood is it's decreasing the importance that the algorithm is putting on variables or areas of variables that are highly discriminatory, while still giving importance to the areas of the variables, the ranges that are highly predictive. And so there's better data and there's worse data. And you should always be looking for better data, and that'd be more complete, more transparent, those sorts of things. But we're stuck in a world where where people are horrible, and we've been horrible for hundreds or thousands of years, and the data reflects that. And so what we've got to do is just try and make it at least a little bit better.
So we need to do better. Is that what you're saying?
Yeah.
Okay, we have about 2 minutes left, and I wanted to close out this panel to make it germane to folks that are in the academic community. So wanted to have your tips in terms of where should you direct people to if they want to delve deeper?
Oh, this is a $1 million question. So depend, I think the big opportunity for the academia is really to help on the technical perspective to really help the research to develop tools for governance. This, I think, is something that actually I'm interacting with a lot of universities where there is a prime type of initiative, and so I think that one is the thing that I will hope the academic community will focus for sure on, because it's going to be instrumental for the future of application of this technology.
Okay.
This is advice for students.
Yes.
Don't do this stuff if you don't like it. I'm weird. I love building algorithms. I love data. I love trying to figure out what's going on. I do it for fun. If that is a horrifying idea for you, I get it, and I think it should be, but that I'm following my passion, actually. And if you don't feel that way, what you're going to find is that you're not happy in your career, and you're not successful in it. So I would really encourage you not to go after whatever the next big thing is, but instead go after what you believe you can be successful in. And then a couple other things that I've just found that I've been really grateful for in my career is having good mentors. And not just using them for networking, but really using them to get advice on how to succeed. And then another one that these kids these days are too wrong about is being willing to be wrong. Be willing to fail, and you'll end up being right once enough or frequently enough that you make a difference.
Great. Well, I think that's a good note to end on. So thank you both, Nick and Stefano.
Thank you very much.